All right, the last two questions in this section are actually the easiest of the problems in this section, examples 3 and 4. And really all they are a strict application of the vertex formula. In each problem, you're basically going to get a quadratic function given to you, and you're asked to find either the maximum value of the function or the minimum value of the function. So all you need to do is identify your A, B, and C, plug into the vertex formula, and be done. I recommend that to start the problem, you make a little rough sketch of the parabola, whether it opens up or down, and on your X and Y axes, write down what they represent. Like, what does the X-axis represent? What's it measured in? What does the Y-axis represent, and what is it measured in? And then, you read the problem and figure out whether you're looking for the max or min, and plug into the vertex formula. And the hardest part of doing this type of problem is deciding whether the question is asking you for the X coordinate of the vertex or if it's asking you for the Y coordinate of the vertex. So that's something you've got to pay attention to. So let's start by looking at number 3. It says that the profit that a vendor makes per day by selling X pretzels is given by the function P of X is equal to negative 0.002x squared plus 1.4x minus 400. Find the number of pretzels that must be sold to maximize the profit. All right, so what we're going to do is make a rough sketch of this parabola. Okay, we see that this is a quadratic function. The highest power of x is 2. The number in front of x squared is negative, so it is going to be a parabola that opens downward. Okay, there is no need to spend time putting this in your calculator. You just need to draw a rough sketch of a parabola that opens downward. Okay, so it's going to be something like this, and this is not accurate by any means. Okay, so you've got this parabola that opens downward. Okay, so something like that. Okay, these are real world problems, so that's kind of why I'm starting here at the origin. Okay, because this negative stuff, whether the x-axis is representing time or whatnot, you usually don't have negative values of those quantities. Okay, anyway, so we've got our parabola that opens downward. Okay, we are trying to maximize our profit. Okay, so this parabola is going to have a max. Okay, so let's talk about what the x and y axes represent. If you read the problem, x is representing pretzels. Okay, so you've got this vendor selling pretzels. Basically, the way this function is working, you plug in x, which is the number of pretzels sold per day, and the output is going to be P of X, which is the profit for that day. Okay, so X is going to represent the number of pretzels sold. Okay, and then the output, which is the y-axis, this is going to represent, this is P of X, whatever, it's going to be the profit per day, and the profit is of course money, so it's measured in dollars. Okay, all right, so like it says find the number of pretzels that must be used to maximize the profit. Okay, so you're looking for this vertex, the max point. Okay, again, the big thing here to recognize is, am I looking for the x coordinate or the y coordinate? Because remember, this vertex is going to have an x coordinate and a y coordinate. The question is asking you to find the number of pretzels. Number of pretzels is an x value. That's what x represents. Okay, so all you have to do here is find the x coordinate of the vertex, and you get that by plugging into negative b over 2a. Okay, so if you go back to our function here, okay, a is negative 0.002, and the b value is positive 1.4. Just plug those guys in. Okay, so we're going to get negative 1.4 over 2 times negative 0.002. Okay, plug that into your calculator. Okay, let's see what we get. Negative 1.4 divided by, put the entire denominator in parentheses if you have an old school calculator. All right, and you're going to get 350. Okay, and that is your answer. Okay, so remember, you have to use units on these things because they're in a context. All right, and remember, X is representing number of pretzels, so the answer is 350 pretzels. Okay, that's the number of pretzels that the vendor must sell per day to maximize his profit. Okay. All right, let's take a look at number 4. All right, it's going to be very similar. You get your function, just apply the vertex formula. All right, the owner of a video store has determined that the cost C in dollars of operating the store is approximately given by C of X is equal to 2x squared minus 18x plus 510, where X is the number of videos rented daily. Find the lowest cost to the nearest dollar. All right, here is your quadratic equation. It is a parabola. Highest power of X is 2. The number in front of X squared is positive, so this is going to be a parabola that opens upward, which is great because we're going to be wanting to find the low cost, which is going to be minimum cost. All right, again, I am just going to make a rough sketch of what this quadratic looks like. Okay, so on my little sketch, I'm going to draw a parabola that opens upward. Okay, and again, accuracy does not matter here. I just need to draw something that opens upward. Okay, so here we go. Something that opens upward is definitely going to have a minimum value. Okay, let's talk about what the X and Y axes represent. Okay, if you go back and you read the problem, let's see here. It says X is the number of videos rented daily. Okay, so X is tracking the number of videos rented daily. Okay, and then the way this function works is you plug in your X value, the number of values rented, and the output is going to be the cost of operating the store if that many videos are rented daily. Okay, so your Y axis is measuring the cost of operating the store. So that's going to be your C of X. Okay, cost is obviously measured in dollars. Okay, we want to calculate the vertex, which again has 2 coordinates, an X coordinate and a Y coordinate. So we need to read the question again to figure out if we need to calculate the X coordinate or the Y coordinate. Okay, so we are being asked to find the lowest cost to the nearest dollar. Okay, so we're looking for the lowest cost. Okay, and the Y coordinate is what's measured in dollars or tracking the cost. So we actually need to calculate the Y coordinate of the vertex here for our final answer. All right, to do this, we actually have to calculate the X coordinate first. Okay, we need to know how many videos need to be rented daily. Okay, and then once we have that X coordinate, we can plug it into the original function to get our Y coordinate. Okay, all right, so let's go ahead and do X equals negative B over 2A. Okay, if we go back to our original function, we know that, let's see, put it over here, our A value is positive 2 and our B value is negative 18. Okay, go ahead and plug those guys into the vertex formula. So we're going to get, be careful here, negative is part of the formula and then B is negative 18. Okay, all right, and you're going to divide that by 2A. Okay, so this is going to be 18 over 4. Okay, and if you put that in your calculator, okay, 4.5, and remember X represents videos. Yes, if you rent 4.5 videos a day, that's going to minimize your cost. I didn't write this problem. I'll tell you where I got it from in a few minutes. Anyway, we're going to pretend that, you know, you can rent 4.5 videos a day. All right, so again, this is not the final answer to the question. You're trying to figure out the lowest cost, the minimum cost of operating the store. It happens when 4.5 videos are rented per day. Okay, so to get the minimum cost, we have to take this X coordinate and plug it into the function. Okay, so we're going to find C of 4.5. Okay, so go ahead and substitute in 4.5 for x into the equation, and then that will be your answer. Okay, so let's go ahead and calculate this on your calculator. Let's see what we get. Oops. All right, so we're going to get 2 times 4.5 squared minus 18 times 4.5 plus 510. Okay, so this is going to be $469.50. Okay, so that is the answer. Remember, this is a cost. That's the minimum cost of operating the store. It happens when 4.5 videos are rented per day. Okay, so this is actually your answer to the problem. This is the minimum cost. It did say in the directions to round to the nearest dollar. So I would accept this, or if you went ahead and rounded it to $470, I would accept that as well. Okay, so that's your answer. Okay, so again, for these simpler types of problems, and actually something like problem number 3 or problem number 4, this is what you can expect to see on the final exam. Okay, you won't get a fence problem. Probably won't even get something as elaborate as the Astros problem with the baseball. You're going to get a simpler question like this, where you're given the quadratic and you're either finding the max or the min, and so you need to plug into the vertex formula. And again, you really have to recognize whether you're being asked for the x coordinate of the vertex or the y coordinate. Okay, so you can expect probably to see something like this on the final exam.